Okay, so now the second insight for what we're talking about here. Okay, we talked about the first insight earlier, and what we can see is the second insight is we notice that when we're dealing with these spaces that we're seeing a reduction in the dimension. Okay, so for example, each of the vertical lines in the previous example, I think it was, which example was it? Let me check. In the example where we were projecting the vector in 3 space to 2 space, right? Each of the vertical lines squashes down to a single point in passing from the domain to the range. So pi was projecting these one-dimensional vertical lines to and maps them to a point, leaving the range smaller than the domain by 1 dimension. Also in the next example, we saw a 2-dimensional domain compressed to a 1-dimensional range by breaking down the domain into diagonal lines. That was the one where we had the diagonal lines where we had x plus y, right? We had that diagonal line, so squished to a single point in that example as well. And then in the other example, where we were talking about the vertical planes, the domain breaks into planes, which then get squashed to a point. And so the map starts with a 3-dimensional domain, but ends too smaller with a 1-dimensional range. Okay, the codomain is 2-dimensional, but the range is 1-dimensional. And the dimension of the range is what matters. Okay, so keep that in mind, because in the next video we're going to introduce a theorem that's going to be useful.